Oh yeah, we lost a lot. There's other people. Jesse. Yeah, Jesse left. Who's the kid who wants to talk? Cameron. He left.
Thank you, Caleb. Thank you. I'm going to quick run through here. I'm going to match myself with one and tell me how one. Good. Okay. All right. Real quick, for those of us who are here, I'll get you. Um, Amanda, Caleb, okay, Mackenzie, Antigua, Nick, Tamia, not here yet. Tyler's here. Lacey, Kate, okay, Caitlin, okay, Joey, Nicholas, Hannah, Hermes, Adriana, Ashlyn, Joan, Marshall, Shannon. All right, girls, I'm learning faces and names. Tell me your names real fast. Lacey, Ashlyn. Okay. Are we all signed in with our other groups? Okay, awesome. Okay, we're looking lonely out there, some of you. Okay. To get things started, I wanted to remind you to make sure that you're keeping up with my math lab. Even though I give you a week, you know, technically really it's due the next time I see your face, but you have some wiggle room in there. And so, like tonight, there will be homework for 1.3, but there's also going to be a quiz that covers 1.2. So things start building up. So if you aren't keeping up, then you're going to start getting behind very quickly. Next week on our lab days, remember this is a 5-day-a-week class, but I only actually physically meet with you 3 times. So on the lab days next week, you will have, like on Tuesday, Thursday, 10 short, you know, problems to do that are just review work again, things that are expected, that's review. But I did want to touch base with those things, making sure that if they didn't feel like review for you, or if it's been a while, you're up to speed with those things. All right? So don't always save lab days just for homework, because there will be other things and you're going to get behind if you don't keep up. Okay? Any questions about any of your homework or my math lab?
Is the quiz timed?
The quiz is not timed. You have 2 opportunities to take the quiz. So again, if you're diligent, take the quiz. You can it'll even let you review and see the types of problems. You can re-practice those problems. The next time you take the quiz, it will be a similar problem but different numbers. Okay, and you have 2 opportunities to take a quiz. Any other questions? All right, we're going. Okay, we're going to start on 1.3 today. And another note that I made myself, remember daily check your emails from Beaufort, daily check your Blackboard, daily check your My Math Lab, okay? Every day. It takes 5 minutes just to make sure you're not missing anything, okay? We're going to be talking about today is complex numbers. So you may have seen these before and maybe not. So to do a quick review of where do they come from, what does it encompass, I'm going to draw a little pyramid. Complex numbers, you know, in our world and in your daily world, you deal with real numbers all the time. Positive numbers, negative numbers, decimals, fractions. All of those numbers are real numbers. Not very often in your daily world and opportunities do you deal with complex numbers. Notice that real numbers, remember I told you I would draw that double R? Double-lined R, that represents real numbers. Remember, that encompasses negative, positive, fractions, whole numbers, everything that you deal with. That is a subset of the complex numbers. Complex numbers are made up of 2 parts. They have an imaginary part and a real part. And that's what an imaginary number looks like, A plus BI, where the A and the B, that's just another real number. So the A is a real number and the B is a real number. That little symbol that I have that looks like that, it's like an E, a backwards E, that means is an element of. So the A is an element of the real number system and the B is also. So your complex number could look like A plus BI, or it could be possible that the A is a 0, and so you only see the BI part, which would be pure imaginary. So that's the type of numbers that we're going to work with today. We're going to add them, subtract them, multiply them, divide them, and simplify them. Okay. When we deal with just real numbers, the world we're used to dealing with, there's no way that we can say x squared equals a negative number. So this is not true in the complex set. They define an I to be the square root of -1. which means that I squared will be equal to -1. So we actually do have a value where if we square it, we get a -1. So you see when we define complex variables, we have that little I in there, all right? And that I is what tells me I'm a complex number. If I have the square root of a negative number, I want to be able to deal with that using some real number properties. Well, I can rewrite the square root of -a as the square root of -1 times the square root of a. Now, the square root of a is a real number, and that's numbers I'm used to dealing with. And so when I pulled that out and wrote that as the square root of -1, that's the complex part, and the square root of a is the real part. Okay, so it's easier to see when I have a number. So if I had the square root of -3, I can rewrite that as I times the square root of 3, because remember, I is the same thing as the square root of -1. That's how it's defined. So when you see radicals and you see a negative underneath a square root, you're going to pull the I out. Okay, you're always going to do that first before you do any other manipulation. So that's the first thing you do. So if we had the square root of -16, before I start trying to apply any of my real number property rules, I'm going to pull that I out and write that as I times the square root of 16. And then what's the square root of 16? 4. So I'm going to write that as 4i. You could put the I in front, but usually we put our variables and letters second. It's just more pleasing to the eye, and it's a standard way of seeing it. But it's not wrong to have the I in front. So negative the square root of -18. Again, if you're going to simplify it, what's the first thing I'm going to do? Pull the I out. That's right. So I'm going to pull my I out. So the first negative is still there, right? That had nothing to do with the negative that's inside the radical. And this is only working with square roots. I don't have cube roots and fourth roots. I'm just dealing with square roots. My I is defined when it's the square root of a -1, okay? Now, they're not going to let me just leave that as the square root of 18. They're going to continue to get me to simplify all the time until I can't take anything else out. I know that from teaching this course many other times that this process right here of simplifying the square root of 18, sometimes people haven't done that in a while, and you might want to practice that. But what you want to do is think about 18. One of the easiest ways to do it is to ask yourself, is there a perfect square that I already know about that's in 18? What do you think? 9. So 18 is 2 times 9. And since 9 is that perfect square, what's the square root of 9? 3. So I can write down my negative, write down my I can take out that 3, and then I'm left with the 2 inside. Okay? Because the square root of 9 is 3, so I pulled that out. So if I want to write this all nice and pretty, probably how I would have written it is like that. Be careful, though, if you do write the I at the very end, you want to make sure that that I is not underneath that radical, okay, because you took it out. It shouldn't belong in there. Also, when you're typing in My Math Lab, make sure that you've spaced over that it's not underneath that radical if you put it there. You can put it in front or behind. Either way is correct. Also, if you were looking at the number 18 and you could not think of a perfect square, you can always go back and write 18 in its prime factorization. All right, so that's another way, and that's all review. But what I want you to do, if you're not sure about that, remember in Blackboard, I have that section that says review videos. You can go and watch that. Do that. Also, starting next week, there'll be, like I said, on Tuesday and Thursdays, there'll be some review problems to do. If at any time, even dealing with the review things, if you don't remember or you're not sure and you've tried and you don't know what to do, at the beginning of class, ask me, and I'll be glad to do problems like that. Okay, so know that even if it's review, you still ask me when you don't understand. All right? Okay. Let's do one more like that, and then we'll move on. The square root of negative 48. So I'm going to give you the opportunity to do that one. So when you check with what your answer says and my answer, we took the I out. We were left with 48 underneath the radical. I thought, okay, is there a perfect square? 3 times 16, and then I was able to take 4 out because 16 is 4 times 4. If you didn't think of that, you can still break 48 down into prime factorizations and then group. Every time you see two things of a kind, you can take one out. Any questions about the basics for dealing with the I? All right.
We have a question here, Madam Mesquite.
Yeah.
About the I.
All right.
That's the way you want. He's a little confused what to do with the I. Can you explain that to them? Like looking at problem where the square root is negative 48. I think it's confusing what he go about from that, you know, if you can just give him some clarification.
Sure. Sure, I'll be glad to. Okay, so when I look at my original problem and I see that I have that negative underneath the square root, that means that I can pull this I out. So the difference between where I started and this next step is just that there's an I now on the outside. And the I on the outside came from the negative that was on the inside of that radical. So one step at a time. Are you okay with that first step?
Yes.
Yes.
Yes,
All right. Yes?
Yes, ma'am, I am.
Awesome. Okay, so then I have the 48 to deal with. And if I'm not sure that I could see 3 times 16 in a 48, I'll write this in a different color. When I'm not sure, I think of the smallest number I can that will divide into 48. So I start with the number 2 because it's an even number. So 48 divided by 2 is going to give me 24. So this is how I would work it if I didn't know 16 would work. And then I know that's 2 times 12. That's 2 times 6. Extend my page. And that's 2 times 3. So if I didn't know what else to do, I can break it down into its prime factorization. So 48 is actually 1, 2, 3, 4. 2 to the 4th times 3. Are you okay with that step?
Yes, ma'am.
Awesome. Okay, so this is underneath my radical. 2 to the 4th times 3 is underneath my radical. Every time I have a power of 2, I can take one of those out. So here I have 2 to the 4th, which is 2 times 2 times 2 times 2. So this group gets to come out, and this group gets to come out. So I have a 2 times a 2 that gets to come out. So that's where I have I times 4 times the square root of 3. Are you okay with that step?
Where did you get the 4 from?
Okay. When these two right here came out, they come out as only 1 2.
Okay.
And then when these two come out, they come out as another 2. So on the outside, I would have I times 2 times 2 times the square root of 3. And that's where my 4 comes from.
Thank you.
Okay. You feel okay about that one now?
Yes, ma'am.
Awesome. All right. Any other questions? So that is very common right there, that whole concept that often it's been a while since people have been working with simplifying radicals like that. So that's why there are those videos in Blackboard and a couple of problems to do that will show up next week on your review days. Okay? All right. Now we're going to start multiplying them, adding and subtracting complex numbers. First of all, if we had, for example, the square root of -7 times the square root of -7. Remember, when you look at a problem and you see a negative underneath a square root, the very first thing you're going to do is pull the I out. So this would become I times the square root of 7 times I times the square root of 7. So just in that one step, this negative that was underneath that radical becomes the I on the outside. Okay, so I'm reminding you I is equal to the square root of -1. That's why this is true. All right, so that's by definition. Okay. Now I'm going to continue to simplify. If I have I times square root of 7 times I times square root of 7, doesn't matter what order I multiply things in. No, order doesn't matter when we multiply. So what I have is I times the square root of 7 times the square root of 7, just changing my order around. So I'm showing you every single step right here. I times I is going to give me I squared. And what's square root of 7 times square root of 7? 7. Okay. If you aren't sure how that happened, this is because square root of 7 times square root of 7 is the square root of 7 times 7, which is the square root of 49, which is 7. Okay, just to remind you. Now, what is I squared at the beginning of class? What is I squared equal to? -1. -1. So this is -1 times 7, so my answer is -7. All right, any questions with that? Okay. So these two i's became I squared, and then I squared is defined to be -1. So if I ever see I squared, I can just rewrite an I squared as a -1. Any other questions? Okay. The square root of -6 times the square root of -10. What's the first thing I want to do? Yes, pull the i's out. So that's I times the square root of 6 times I times the square root of 10. What do I want to do next? Yeah, like, yes, multiply them. So that I times an I, are you okay? Everybody okay if I wrote, I'm going to go ahead and write that as I squared? And then for my square root, because they're both square roots, okay, because that's a square root of 6 and a square root of 10, then I can write square root of, and underneath it is going to be 6 times 10 underneath there, okay? I couldn't do that if one was a square root and one was a cube root. But because they're both square roots, I can write this as I squared times the square root of 60. Okay? I'm done, except if I can take anything out, I have to do that. And I think I'm going to be able to take some things out of 60. So I would go through that exact same process that I did with the number 48. All right? So I'm going to give you a chance. Take the number 60, either find a perfect square or write it in its prime factorization and decide what you can take out and what gets to be left inside. So I'm going to give you a second to think through that. If you decided to write 60 in its prime factorization, you would come up with 2 squared times 3 times 5. There's only one 5, so it stays inside. There's only one 3, so it stays inside. But there's 2 squared, so it has an exponent of 2. It's like playing Go Fish or cards. You know, when you have 2 of a kind, you can lay that down, right? So this is like every time I have 2 of a kind, I can lay it down, but it's like a book of 2s. It's not 2 2s, it's just a book of 2s. So when I have 2 squared, because I have 2 of them, I can pull that out as a book. Just there's 2 on just the number 2 on the outside. So this becomes 2 times the square root of 15, and that's getting squished right up here. Because the 3 times the 5 was left on the inside. So that's just breaking down the square root of 60 part. Okay? So what was the I squared? What was that going to be? A negative 1. So I'm going to have a negative 1 from the I squared times 2 times the square root of 15. Clean that up. And I have negative 2 times the square root of 15. Now, I have gone like every teeny tiny little step, and so you may not need to write down all of those steps, but I did it in case someone wasn't sure. Okay, as you look back through that problem, does anybody have any questions with that one? Okay, notice that I said earlier, because I had the square root of... Did somebody ask a question?
Yes.
Yes.
So when you break it apart, how do you always choose like the bottom number you get and see how many times you have it? So
Yes.
That's the power you use?
Yes. Okay. So for example, I'm going to choose another number other than 2 because there's too many 2's. Okay. So suppose I did a different example, and I had taken some number and I had broken it down into its prime factorization, and I have the square root of 3 squared times 5 to the 4th times 7. So I just made up a number, okay? Now, if I want to simplify this, because this is a square root, you see there's no number written here in the index part. If there's not a number there, it's understood to be a square root. Okay, we use it so often, it's just understood. If there's nothing there, it's a 2. So every time I have 2 of a kind, I can take it out. So when I look at 3 squared, I have 2 3s. So I get to take out a 3. So the 3s are done. Now I'll look at my 5s. I have 4 of them. Every time I have 2 of a kind, I can take it out. How many times could I take 5 out? 2 times. So I could take a 5 out 2 times. Okay? And then there's only 1 7. So outside here, I'm going to have whatever 25 times 3 is. Well, 75. Does that help you? I don't know
Yes,
who I'm
but
talking to.
I was asking about when you're like factoring out when it was like the 4 times 15.
Okay.
So like, since you got 2 2s at the bottom, that's how you know it's 2 squared. Oh, okay.
2. Oh, how I know. Okay, I see what you're saying. Yes, right there. That's how I know I had 2 squared. Yes.
But how about on the top one where you knew you had 4 2s?
Oh, okay. What I was doing is I was starting with the number 60 and just thinking, do I know numbers that multiply to give me 60? And that's the 2 numbers I came up with in my head first. So I wrote the 4 down and the 15. I could have and should have already, also with my 15, wrote down 3 times 5 so that I broke every single number down as far as I could. So the 4, when I broke it down, that's where I got my 2 and my 2 from. And my 15, ultimately, my 3 and my 5. But you're right, because I have 2 2s, that's where I get 2 squared from. If I had 3 2s, it would be 2 to the 3rd power.
Okay, I get it now.
Awesome. Any other questions? So quick review. So however many 2's you have, this will become 2, and 1, 2, 3, 4, 5. That would become 2 to the 5th. Okay. Now before, I had the square root of 10 times the square root of 60, and I put that together and called 2 times square root of 10, and that became square root of 60. That's because they were both square roots. That's true when you multiply. It's also going to be true when you divide. So with this next example, I'm going to have the square root of negative 20 divided by the square root of negative 2. They are both square roots. So I could put them all under one big square root as negative 20 divided by negative 2. But what's the first thing I didn't do that I should have done? Take out the i's. What's going to happen to my i's? They'll cancel out. What is 20 divided by 2? 10. Can I break 10 down? No, that's 2 times 5, and neither one will come out. So I want to take that I out first because technically rewriting that under one big radical is using a real number property. Okay, and to use a real number property, I can't have any i's. Okay. Any questions about that? All right, so I don't know who is who on my screen. Columbia, wave at me. Who's Columbia? Where are you, Columbia? Hi, Columbia. Okay, Columbia, you get to do this problem. Okay? So y'all can collaborate and decide what you believe the answer is supposed to be. Everybody else, you work it and see if you come up with the same answer as Columbia. And whenever you're done, Columbia, you just let us know. Choose a brave spokesperson. Okay, are you ready, Columbia?
I think it might be too high. So look, so you take out this eye.
I got y'all off mute, so it's a speaker.
I'm just
Okay.
gonna give a shot at it. I'm not sure if it's right or not.
All right.
So after you take the eye out of the square root of 48, and so
Right.
I think that would become the I to square root of 24, right? And then over the square root of 24, and I think the square root of 24 should exit out, and then it will turn into a 2i.
Okay, you've done everything almost perfectly, except you took the 2 out. When you took the 2 out of the square root, that really meant that you had a 4 on the inside. So you took too much out initially, because that would have only left you with 12.
Yeah, you're right.
Okay, 48 divided by 24. I do get that 2, but that 2 is on the inside. So you are almost exactly right. It's just I times the square root of 2. Very good try. Thank you. Any questions about that one?
Can you go back up, please? We weren't finished
Yes,
writing
I
it down.
will.
Thank you.
Sure. Okay, Plymouth. Where's my Plymouth crew? I see Plymouth.
Hello.
Okay, Plymouth, I'm going to let you take a stab at this one.
Okay.
When you think you know it, walk me through the steps. Don't just tell me the answer. Like, say, the first thing you should do is, whenever you're ready.
Okay. Okay, so that's 12. That's going to be 4. We got a 4 and 3. So that should be negative 2. Square root of 3. Okay. So it's on me? Yeah. Okay.
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 Tell
the
me
first
what
step
to-
is- Okay. The first step I did was take the negatives out of -6 and -2. So I got I with the square root of 6 times I the square root of 2.
Beautiful.
I decided the times I said that should be I squared, and then 6 times 2 should be the square root of 12.
Yes.
I broke down 12 to -2, the square root of 3.
Okay, because you went ahead and wrote I squared as a -1, right? Yes. Okay. So she went ahead and said I squared is a -1, and then she looked at 12 and she said 12 is 4 times 3, and she took that 4 as a 2 squared. So the square root of 4 is 2, so she took that out. Okay?
Okay. I crossed out the square root of 3 for both.
Yes?
So the answer should be -2.
Yes, very good.
Okay.
Very good. Very good. Very good. Now, another way that you could have solved this is when she got to the step, she could have, like in our previous problem, because they were both square roots, she could have written them as I squared with this big old square root of 12 divided by 3, which is 4. So you'd have a -1 on the outside, and the square root of 4, the square root of 4 is 2, and you still get -2. So as long as you follow the rules, you might take a little bit different path, but if you're following the rules, you'll get to the same answer. Okay? Very good. Thank you. Often in your homework, you'll be asked to leave your answer in standard form. And that is of the form A plus BI. So if I'm given this particular situation and I'm asked to simplify it and leave it in standard form, one thing that you need to pay attention to is that because it's -8 plus the square root of -128, you need to make sure that when you do your division, that 4 has to be divided into each of those, not just one. If it was multiplying, then it would just go into one of those. Because it's a plus or a minus, adding or subtracting, has to go into both of those. So the first thing I'm going to do is take that I out. And then I'm going to write each part as dividing it by 4. So -8 divided by 4 is -2. And just for time's sake, I'm going to tell you about 128. 128 can be written as 64 times 2. 64 is a perfect square. 8 times 8 is 64, so I could take 8 out, right? I'm still working. And so 8 divided by 4 is 2. And again, that I can go in front of those numbers. It can go behind it. Just make sure it's not up underneath that square root. In my math lab, when you are not sure how they want you to leave an answer, go up to the right-hand top where it says Help Me or Show Me. You can click that button and it says Show Me an Example. Click that button and just go all the way through the entire problem. See how they leave their answer, and then you'll know what form they want you to leave it in, okay, if you're not sure. Okay? Because you can do all that work and really have the correct answer, but if it's not typed in their form that they want, they're not going to recognize it. Okay. Any questions so far with just manipulating some complex numbers? Okay. We're going to add and subtract them, which is very easy. Adding and subtracting is just combining like terms. That's all you're doing. Three minus 4i plus negative 2 plus 6i. So you see I have one complex number plus another complex number. But if you step back and look at the whole problem, those parentheses, there's only an addition sign in between those parentheses. Are those parentheses necessary? They're not. Those i's are just like a variable. Okay, so just add your imaginary parts together, add your real parts together. You're just combining like terms. That's what you're thinking. So you've got a negative 3, a positive 3, and a negative 2. So that's going to give you 1, and a negative 4, and a positive 6i. So that's going to give you positive 2i. And that's it. So you're just combining like terms. The only thing to be careful of is when you are subtracting, this time, do those parentheses matter? Yes, they do, because that subtraction sign is in front of those parentheses. So in order to get rid of those parentheses, I need to distribute that subtraction sign. And be sure to take it to each term in that set of parentheses. A common mistake is they would take it to the 6 but forget to take it to the negative 7. And then it's just combine like terms again. So you're going to have negative 10 plus 10i. So you're just combining like terms. Any questions about that? All right. Now we're multiplying them. This is just like when you multiplied binomials. You're just going to FOIL, okay? First, outer, inner, last. Okay? 2 times 3 is 6. 2 times 4i is going to be a positive 8i. Negative 3i times 3 is a negative 9i. And now be careful here. Negative 3 times positive 4 is a negative 12, but that's an I squared. And what is I squared? A negative 1. So that negative 12 is actually a positive 12. So that's the only little new thing when you're multiplying. So you just combine like terms, just like we did before. So I will have a 6 plus a 12, that gives me 18. And a positive 8 and a negative 9, that's a negative I. When they talk about standard form, remember how standard form looks like A plus BI? I think MyMathLab will let you use a subtraction sign in there. If you're not sure, I mean, it is fine to do that. It's correct. But if MyMathLab doesn't want it typed in that way, you can check like I told you before. Okay. Any questions about that? Okay. I squeeze every minute out of it that I can. Conjugates. You've got your two complex numbers, but one has the plus in the middle and one has the minus. So they're exactly the same numbers, 3 plus 2i. but it's 3 minus 2i for the second one. They would be considered conjugates. They don't have to be multiplied together, but I am going to multiply them together. I do it because it's going to get rid of that I squared. Now, I'm asking my little technology person, is that right that 2:28 means I have 2 minutes left? Okay, I have 2 minutes left to do what I can do. All right, so when you go to do your homework, probably at the very end, you may go, we didn't talk about that, so I'll talk about that next time, however far I don't get, but I'll go ahead and just set this problem up. 3 plus 2i divided by 5 minus I. So I've added, I've subtracted, I have multiplied, now I'm going to try to divide. So I have a complex number divided by another complex number. Do y'all remember way back in algebra when you had to rationalize a denominator? You remember that maybe? Okay, this is what we're going to do is similar to rationalizing a denominator because it has that I is a square root. And we don't want any square roots in the denominator. I'm just going to set this problem up and then I'll start here next time. So what we're going to do is we're going to multiply top and bottom of that fraction by its conjugate. Okay, so I know you're getting ready to leave me. In my math lab, you have homework for 1.3 and you have a quiz for 1.2. Okay? Have a good afternoon and we'll start here next time. Yes, the time, and you have 2 tries to do it in.